In this example, we'll be looking at how to use velocity time graphs in solving problems involving constant acceleration. So the question reads, a car is traveling along a straight horizontal road. The car takes 120 seconds to travel between two sets of traffic lights, which are 2,145 meters apart. So first thing which I'm going to do is I'm just going to draw a little diagram just to kind of see what's going on here and try and represent the information. So we've got, the car starts from a point and goes to a second point, and it says they are 2,145 meters apart. So at the first set of traffic lights, and moves with a constant acceleration for 30 seconds until its speed is 22 meters per second, is what it's saying. So it starts from rest, so the speed here is 0 meters per second, and it goes to 22 meters per second at that point. And throughout this journey from the start, let's call it A to B, it is constant acceleration, and it says here it's accelerating for 30 seconds here, so time here is 30 seconds. And the car maintains this speed for t seconds afterwards, and the car then moves with constant deceleration coming to a rest. So from here, from point B, let's say it goes to point C, it maintains that same speed, so it'll have 22 meters per second at that point. And it maintains this for t seconds. The car then decelerates, moving with constant deceleration, coming to rest at the second set of traffic lights. So the second set of traffic lights here, I'll denote using the letter D, and it comes to rest here, 0 meters per second. And it's got constant deceleration here. It doesn't mention anything about the time, how long it takes here, so I'll leave that bit blank for the time being. Okay, so that's transferring all of the information given to us. Well, just missed out one bit here, that the distance between the two traffic lights is 2,145 meters. And the car takes 120 seconds to do this whole journey. So 120 seconds is the whole journey. So here, what I've done is taken all the information given to us in the question, the 120 seconds there, the 2,145 meters there, starts from rest and moves with a constant acceleration until it reaches 20. So rest, 22 meters per second, takes 30 seconds. Car maintains that speed for t seconds. So it maintains that same speed. It then moves with constant deceleration, coming to rest at the second set of traffic lights. Okay, so I've got all my information here for the whole journey there. It then goes on to say part A, sketch in the space below a speed time graph for the motion of the car between the two sets of traffic lights. So the two sets of traffic lights that we've got here is traffic light at A, so there, traffic light, and then at D, there's the second traffic light. So we need to essentially show this whole journey on a speed time graph. So let's put our speed here. We've got speed along the y-axis, and we've got time here. Time is in seconds and speed is in meters per second. So it starts from the point A at 0 meters per second, and it has constant acceleration till it reaches the point B. So there is point B, and at that point its speed is 22 meters per second, which will indicate there, and it takes 30 seconds. So at that point, this length here is 30 seconds. And it maintains this speed. So we've done 0, 30, 22. It maintains this speed for t seconds until it gets to point C. So there's point C, and it takes t seconds there. So that's t seconds. And then it decelerates to a speed of 0 meters per second, rest. We don't know what that further time is, but that's the point D that we've got there. We know that this whole length in terms of time along the x-axis is 120 seconds. So there's our velocity time graph drawn, part A answered. So part A is complete. Let's go and look at finding the time, value of the time. Now we're given that this entire journey is 2,145 meters. Now the area of a velocity time graph represents the distance traveled. And the distance traveled here is 2,145 meters. So let's find another expression for the area of this. It's a trapezium, as we can see here. So let's find the equation of a trapezium. Area is equal to the two parallel sides, a plus b, divided by 2 times height is the area of a trapezium. Let's go and find out what these are. So the two parallel sides are this, which is t seconds, plus that whole length, which is 120, divided by 2 times by the distance between the two parallel sides, which is this distance here, which is 22. So this then simplifies, and we know this area is 2,145, so we can say 2,145 is equal to t plus 120, and the 22 divided by 2 gets us 11. So from here we can do 2,145 divided by 11, we get 195 is equal to t plus 120, which then gets us 195, take away 120, so we're left with 75 seconds is the time. So this is part B, completed, find the value of the time. Then it goes on to say a motorcycle leaves the first set of traffic lights 10 seconds after the car has left the first set of traffic lights. The motorcycle moves from rest with a constant acceleration, 8 meters per second, and passes the car at the point A, which is 990 meters. They've talked about the point A. Now I've already used point A as my starting point rather, so I'm going to change that to E. Just a different letter, that's all, to help me not get confused. Now this point E is 990 meters from the first set of traffic lights. So when the motorcycle passes the car is moving with a speed of 22 meters per second. So this bit's really important. When the motorcycle passes the car is moving with a speed of 22 meters per second, means that where the motorcycle will pass the car is happening at this journey of the car. This journey of the car is happening somewhere here. And so there is a particular point where this happens. So let's just say the point E is somewhere here. So I don't know what this time is. I'll label it as a different letter here. I'll call it lowercase t. So what am I after then? I'm after this time here, because the question's asking me find the time it takes for the motorcycle to move from rest from the first set of traffic lights, to the point A, or in this case point E is what we're calling it, okay, since I relabeled it point A to E so as to not get confused. So let's take a look at this. We know it's here, so really we're after this area here. So again, we have another trapezium, as we can see here, this shaded region. And we know the area. We know what this area is because in the question it told us that the motorcycle has traveled 990 meters from the first set of traffic lights. Okay, so 990 meters. So that tells us that this distance, this area is 990 meters. It's the area here. So let's set up another equation here for part C. So for part C, we'll set up an equation for the area of this trapezium. So that's going to be T, which is the parallel side on the top, plus we have 30 plus T, which is the length along the bottom there, 30 plus T, divided by 2 times by the distance between the two parallel sides, which is 22, and we know this area to be 990. So let's write down 990 is equal to 2 lots of T plus 30, simplifying the bracket there, and 22 over 2 again is 11. So we go and do 990 divided by 11, and that gets us 90. So 90 is equal to 2t plus 30. And then we got 2t is equal to 60, and t is equal to 30 seconds. So this t equals 30 seconds here, which we found is the time here. So we already have 30 seconds prior to that here, so plus that 30 seconds. So the total time it takes for the car to travel 990 meters. So for car is 60 seconds. Now the motorcycle starts 10 seconds later. It says here, leaves 10 seconds after the car has left the first set of traffic lights. As it starts 10 seconds later, it means it's been traveling for 10 seconds less. So the motorcycle has traveled for 50 seconds. Let's go and take a look at the last part, which is asking us to find the acceleration of the motorcycle. Now, for this part here, we know that the motorcycle started at the point A and it moved with a constant acceleration until it reached the point E. And that whole distance that it traveled was 990 meters. And the total time, which we've worked out previously, is 50 seconds there. It took 50 seconds to travel that distance. And it started off with 0 meters per second because it told us that the motorcycle started from rest. So we're going from A to E. We've defined the 2 points which we're going to do SUVAT between. We'll take right as positive, go and write down SUVAT. We know that the total distance traveled here is 990 meters. U is 0, V is unknown, acceleration is what we're trying to work out, and the time taken is 50 seconds. So the equation that relates SU, A, and T is S equals U T plus half AT squared. Substituting our values here gets us half A and then 50 squared. This then simplifies to 50 squared, which is 2,500 divided by 2, which is 1250 A. And so our acceleration then is 990 divided by 1250. So we have 0.79. So that's 0.79 meters per second squared is equal to our acceleration.